you know, it will notify you, and you can, you know, be able to go through it. So as I said, all that being said, we have in the house our regional lead is already on the call. His name is Mr. Seyi Oluwawumiju. Mr. Seyi Oluwawumiju happens to be one of the people that brought me out of oblivion when I started 2021. Immediately I got certified as a Power BI analyst. Was one of the people that really gave me opportunity to grow in this space. He's a Microsoft regional lead for Nigeria and West Africa, and is the number one. Yeah, I'm a community lead. It's also a community lead, but you know, there are community. So it's in stages. So he's number one in Nigeria and West Africa. And yeah, he has been doing this for more than 20 years. And so it's a big fish when you talk about AI, MS365. So having him speak to us today is a rare privilege. And so, ladies and gentlemen, I have the honor of introducing and our speaker for today, Mr. Seyi Oluwawumiju. Don't forget, he's a Microsoft certified trainer. He's also Microsoft most valuable professional, and he has decades of experience. He's on his own, but he has worked for big tech company in Nigeria. Thank you so much, Mr. Seyi. You have the floor, sir. So you can just appreciate him by an emoji, thumbs up. Just you don't need to unmute your mic. Just appreciate him. Mr. Seyi, you have the floor, sir. The floor is yours. Hello, Mr. Seyi, can you hear me? Okay. I'm seeing your screen. Confirm that you can see Mr. Seyi's screen. Okay, thank you, Albert. Thank you for that feedback. Mr. Seyi, you cannot hear your voice yet. Maybe you need to unmute your mic. We cannot hear your voice yet.
So he's not muted, but we can't hear him. He's speaking.
Okay, we can't hear you.
Hello.
That is
okay.
We can hear. I can hear you now, sir. I can hear you now, sir.
Okay. Sound check, sorry.
I can hear you now, sir.
So sorry for coming late. It's not my usual practice. I have to be driving down from where I was having a conference for this meeting. So just apology, please, for that. And we quickly go into the business of today. And today we are going to look at a very, very important aspect of technology that is taking a lot of buzz around us, and that is AI. And from the organizer, we are basically trying to introduce you to this. And I coined the topic as artificial intelligence, which is beyond basic, looking at practical impact and making industry ready for this. And it's going to majorly be built on Microsoft AI 900 Fundamental Module 1. So I think Rashidi has done justice to who am I. I'll just take a cue from there. My name is Oluwa Seyi, and these are years I've been in Microsoft technology. Let's just go straight to today's event. And today, our agenda briefly. I don't know, Frank, how many minutes do I have? So I'll start managing my time from now. Frank,
okay, you have like another 1 hour.
Okay, great. So I have an hour to be able to push this through. So today's agenda, basically, we are not going to go straight into AI. Now, I like to always build my foundation on what the precedent to AI. And one major precedent to AI is what had happened in transformation. As the year elapsed, every time we have this industrial change, over years, the first wave, the second wave, I think we're in the fourth wave now of industrial revolution. Each year that we have this change of technology, change of industry concept, of principle, of way of life, there's always one remarkable thing that comes up, and that is what we call transformation. In days of 1749 BC, where we have the steam engine coming into light, a lot of transformation happened, a lot of change, and brought about mass move in terms of industrial changes, commerce increase, and from government down to businesses, we are having this quantum leap in terms of business processes. So also, we need to first establish that. What is digital transformation? And afterward, we now look at, following the module we have in AI 900, we need to look at the concept behind AI. We need to look at what is machine learning. Now, AI generally is just a mimic of human, computer program trying to do what a human can do in terms of precept, in terms of reaction, in terms of object detection. Now, having that in mind, we all need to know how does it bring about this concept? Writing the algorithm is not all. There must be a learning process, like a child growing. Now, the basis of child growth is always start with the child growing from childhood, having knowledge of the environment through the parent, especially the mother, then learning more from the environment and picking up to make this a reality by standing up. Sometimes it falls down. Sometimes you find the child doing something in error, which will be corrected by the environment or the parent. So all these are done by constantly training and exposing this child to reality and to changes. And the same thing with AI. We need to also understand the subset of AI is called machine learning. And machine learning generally is a technique, a procedure, a model, a programming way where we try to train. Now, in the software development, especially in software, programming generally is a step-by-step algorithm where you move from one point to another to ensure you get a result and output. Now, in case of machine learning, we are not going to go through the program. We are just going to leverage on data, and we inject data into the algorithm to create what we call a model. And that model is what we're going to use as our output, our influence, and I call it the bullseye. That means at that point, we have established a fact that any other object that comes through that will be able to get an inference from that this is the result we are looking out for. Then finally, we are going to look at fundamental of the services. Azure have some AI service on board. We're going to look at it. Then we look at practical applied solution we use AI for, and we kick in for Q&A. So let's go right into the course today. So digital transformation. Now, I will not start without referencing history. Now, artificial intelligence generally was actually, there is this person called the father of AI, which is called John McCarthy. Now, around 1956, precisely after Turing experiment in 1950, John McCarthy was able to pioneer what we call a conference. That conference was called Dartmouth Conference. I think it was in the US, where it brought about people from all over the higher institution, then research institute, to come to talk about a subject that was 4 years ago, or I think about 6 years ago, opined by a particular scientist called Alan Turing. And that brought about the language, which is called artificial intelligence. So John McCarthy is considered as a father of artificial intelligence because of this move. And that's where the term started. Now, Everything we're going to do today is going to be basically based on a tool that leverage on people's experience. What do I mean by that? Every effort that technology put forward are actually basically built on how people look at it, how people conceive it or adopt it. So in sense, what I'm saying here is that every digital transformation that has ever happened is a partnership of the people experience with the technology at that time. So let's now look at digital transformation. We have established the fact of the principle that was cultivated by the naming convention called artificial intelligence by a man called Alan Turing in 1950. However, the exposure of this, the conception of that became widely acceptable when John McCarthy did it in 1956. Let's now take the journey now. Where did it start from for us in our days? How did we get to this point? Let's look back. Digital transformation. Now, what is digital transformation? Now, history lane from the time of steam engine in 1780, where steam engine was the pioneer technology that started the first industrial revolution. A lot of e-commerce came in, a lot of businesses came in, transportation was eased, goods was passed from one country to another. That was not the light. A lot of transformation brought about increase in business and technology. That followed by electricity in 1817, another revolution started. Then we have the one of electronics and IT in 1969 and 1970. However, the boss of AI digitalization started in 2015 and 2016, down to what we have here. So at every time, there's three major things that is conceiving this. Now, talking of printing press in 1439, talking of automobile in 1885, or talking of internet in 1980. All of them have three major things that conceive this. One, the need. Woman, people, you and I, our need changes. Time elapses. A lot of things conceive, a lot of them change, a lot of them come into place. And at every time, there is this need that is arising. Human is expecting another innovation. And each innovation brings about what we call change. And that change brings human progression. So we can see a landslide of changes that have occurred in technology from down when Jesus have not, before the birth of Christ. That is 14,000 BC, when we have this big wheel, that we have a pedal. That was the first initiation of technology and revolution of automobile. And it ran down to telephone in 1956, down to automobile in 1885, and internet in 1980. And we are in the AI time now, which are all basically run through digital transformation, industrial revolution, and change at each time. So what am I conceiving here? Three things that make this to happen: need, innovation, and progress. Now, what am I saying here? Technology is about you and I. Technology is about people in this class. Technology is about we that have a need. I need to have my approval done when I'm in my bathroom. That need came. Power Automate came into place. Power Apps came into place. We can create the app without knowing code. And each of this code, I can approve it through an automation process. And when it gets to me, I can approve it while I'm seated in my toilet. People make the change in every industry, from consulting to manufacturing. Every industry you can see in this picture, all of them basically is built on people experience. This is circle. It keeps going. The need come because even today, nobody can tell the net wave. We're in the fourth wave now, of which AI is the major thing that's propelling industrialization and changes in technology. What will happen in 2 years' time, in 5 years' time? Although I saw a statistics that by 2032, AI must have grown over billions of dollars. What does that mean? AI keep growing, people still injecting agent. We're in the agentic time now. A lot of things is coming into picture that we can do. So human needs keep changing, innovation keep coming, and progress is a circle. It's like a rat race. It keep going, and we continue like that until when the world comes to an end. Now, I come from Ondo town. I always make this analogy when I make my class, give my class. I am from Ondo town in Ondo State, and from history, my grandfather migrated from a village called. You're going to hear my story more when I start explaining this. Migrated from Okego down to Ondo town. Now, I happened to go for holiday before my grandmother died, that I think late early 2000. And there's something unique about my grandmother. She's a farmer. And every time we go to the farm, we walk miles to the farm. She starts heaping the ground. After heaping the ground, she touched the soil. She can tell when he's supposed to plant corn. Sometimes we plant cassava. Sometimes we plant yam. All this has been an experience curve. She have learned from her own father, from her own uncle, to our time when she was growing. Till then, that same intuition has been making reference. But when we talk of the output of what she was giving, even at her age, she was almost 70 at that time, we can't compare to what this young lady you are seeing in my picture. She is a farmer. I can tell you, I can bet it, she's a farmer. But look at, she's not using big holes and the rest, but she's using a technology that is revolutionizing our change, making our farm produce to increase more than what my grandmother did over years. And that is the twist here about AI. Now, she'll be able to measure here the soil temperature. She's able to know the pH level of the soil. She know what she can plant. You can say how green the farmland is. My grandmother from Ondo town spent ages and time and experience to get to this level. And that brings us to a twist here. The world has changed. Now, for you to get into AI, you must be able to change your perception of what you know before, because AI has come to make a dramatic change in the way we do things, we walk through process and make things happen. There is an old way and there's a new way. And this is where our journey starts this Saturday. What brought about digital transformation? Three major things that is striving and pushing this effort till now. One, the cloud technology. Two, the data that is the fuel of oil. They call it the fuel or the oil or the gold of our time. Three, the intelligence that is coming from the combination of the cloud, the data, and now we're in the age of intelligence. Now let's look at it one after the other. Please follow me, just like the plane is about to lift up. We are getting there gradually. We are still going to look at some feature of AI, do some demonstration practically of what AI can do for us. Now, the cloud technology. Now, sometimes I remember between 5 to 10 years ago, when cloud became prominent for Microsoft, especially, they were late in adopting cloud technology and moving to that speed. However, people like Google, people like AWS have been in that sphere for a long time, especially AWS, which still managed to lead the market share. I don't know whether it has been overtaken by Microsoft, but I know they were leading over some time. Now, what is cloud? The first question we ask ourselves is, in the introduction of cloud, is how do we adopt to cloud? Now, I take reference to a great man in Africa called Nelson Mandela, blessed memory. When Mandela, before he died, He was a man that went to prison, did a lot of things to make change in terms of the society before he died. But however, when he was talking, he made reference to two things, which I took down and I was able to picture here. He said, everything he has done in life, despite going to the prison, doing all those things, he never lost. He's not losing. His life is either to win or learn. To win or learn. That means, just like this goldfish, this guy, this is Shay here, 5 years ago. It took me time before I can adopt to cloud, because there's so many things that came to my mind. Why cloud? What is cloud? And that was until I did this leap as this goldfish to meet others, I was able to understand some facts. Why cloud? Now, what is cloud? Now, there's several ways we can capture why cloud came into being. One of them is a collaboration effort that is within company businesses all around the world. Now, in the past, collaboration has been disjointed because everybody have their own server in their own server room, their own data center. And when I want to collaborate with a customer, with a client, with a contractor, what I need to do is to have a way of federating with them commonly, creating firewall that allow VPN to have access. Now, this disjointed the way things work. It delays sometimes. You cannot co-author things. You cannot have proper versioning of document. And that was one major disadvantage that cloud came to step in. Availability. 2, resources, especially when you're on a common ground where you have your resources across the world. And each of these resources are dispersed throughout different sector, different country. How do we combine this? The resources brought a common ground, but the availability of it are in silo areas. How do we bring this together? And that is one major shift that happened when COVID-19 came in. It brought cloud technology into the picture, that we can have resources wherever you are, have the same resources, do whatever you want to do without hesitation. Then other things like mobility, mobile phone, smartphones, keep increasing, keep changing, and we need a way by which we can have it in our center, use it as a work tool to make things work. Now, all this together give us the reason why cloud. Then, what is cloud itself? Now, let's take a step back and see. Doctor says you breathe in and breathe out. What is cloud? That's the question. Now, I did a research by myself, one major thing about cloud is a definition that involves, now, if you are into engineering and maybe your major is engineering and you're coming up, and when you talk of design, especially design is one of the core concepts of engineering, being able to bring to picture what you want to achieve. Now, doing the design methodology, you'll be able to describe what you want. Now, one tool you can use for that is a visual diagram. Now, in visual, whenever you want to talk of internet, you see a olive shape that comes with different form of head called internet. So when I went to whatis.com, the first thing that came into their definition is that cloud is an inspired symbol that often been represented with internet in terms of its flow. Fine. Can I go further to look at this? Yes, we can do. How do we define cloud? What ways can we define cloud? So I went further to look at cloud computing. What is the change that has occurred? What are things? Sorry, my PowerPoint went off. Bring it back. once I click this, my clicker twice, it just shut down my PowerPoint. Come back now. That is the lab area I want to use. So the question now that came in is from the definition of cloud is, how do we picture cloud? Can we concept it and try to beat it down into different bits to be able to understand it? Let's start from the central idea of cloud. Cloud is more like utility, NEPA, Eco PSC, or Ikeja PSC. What does that mean? Or water corporation. Somebody give me a service that I have to pay for. Then it comes with what we call an agreement called SLA, and it's under a service-oriented architecture that as long as I am giving this service, I'll be able to pay for it. Anytime I stop the service, I don't pay for it. And I should have the service everywhere. So from that note, the central idea is that cloud technology are people, company that give you services that you pay for. Two, let's look at in terms of character of a cloud. One of the character of cloud is scalability. You can use the resources, reduce the resources, or increase the resources. It's elastic, and you can have access to it everywhere. It's available and it's reliable. Now, the management of it is a relationship, a responsible matrix, where 100% of responsibility, 80 or 40 or 60 lies with the third party that deployed this data center. It's portable. You can access it to anywhere, and its performance can easily be optimized because the hardware, because one thing you know about hardware refresh is that it's a consistent change. Just as I mentioned, they need the innovation and progression. They need innovation and progression. It's also in the hardware industry. Dell, HP, they keep going to research, keep bringing things up to make innovation, to bring change, to bring all these things. And that tells that you need a system that is consistent and stable. And that's what cloud can give you from character. Now, in terms of technique, now as individual, I might not be able to invest in buying server all the time. I might likely use things that can easily give me that by using what hardware virtualization. And I also want to distribute my computing and web services all over. At any time, I can have access to it. So we're going to go on speed dial now as we run through pictorially how a data center is. Just like a collection of servers, probably network, and security is in check, and cooling, power are easily is accessible to the owner or the provider of this service, this cloud, and all. So in generally, cloud can be for me as a startup where I can just get my resources on, I can start production. It can be a where I can have all the software and go, like software as an asset, like M365 have over 60 apps, which if I buy it individually, it costs me through the nose. So all this, it can also be a place where I don't need training my staff because the third party is already providing those services for me. It's helped me to easily communicate to the network. The cost of infrastructure are reduced. So in nutshell, what is cloud? Now, there is a particular talk, meanwhile, by Microsoft some years back, which I put here. I'll just run through it. What is cloud? It's about 2 minutes video. Just listen to it. Can you hear it?
You know,
Please turn up if you can hear the audio.
yes, you are hearing.
Okay, thank you.
We can hear it, sir. We can hear it.
Thank you.
It's no longer talking.
Said?
It's moved. It's no longer the audio is no longer responding.
We can't
Initially
hear.
it was, but it's not playing again. No
Okay,
audio.
let me just reshare it, and let's take it from there. Allow audio. I'll share it again, then I can play it now.
The internet. Perhaps a more practical way to think of the cloud is a utility that companies of all sizes are rapidly
Can you
taking
see it?
advantage of.
Okay, thank you.
Yes.
It's fine now.
Okay now.
Okay.
Just as gas and electricity providers supply services to businesses and homes, public cloud providers supply secure, reliable, and scalable computing from a shared data center that you simply plug into. Traditional on-premises computing is expensive and at times restrictive. You have to pay for the hardware, the software, the licensing of electricity and floor space. Not to mention the time your staff has to spend protecting and maintaining it all. Cloud computing, on the other hand, empowers companies to run faster and cheaper than ever before, simply paying for the resources they consume, when they consume them, and bursting in scale when needed. It's not just pay as you go, it's pay as you grow, and provides companies with the confidence to innovate by creating applications and services on the fly, testing new ideas and features with limited risk and minimal outlay. This is the power of the cloud. It's still servers, storage and networking, but instead of worrying about the maintenance and upkeep, customers can now spend more time innovating and creating new business opportunities. With Azure, Microsoft's cloud solution, customers can relax with the assurance that their valuable assets are protected by a global workforce serving over 140 countries and working tirelessly to ensure consistent and continued availability. What's more, with strict compliance and regulations to adhere to, you can be assured that your information is protected both in transit and at rest, never falling in the hands of unattended recipients and ensuring that you hold the keys to your kingdom. This is what drives customers to the Microsoft public cloud. And along with the advanced security systems built right into the very heart of the platform, you can breathe easy knowing that you're always running the latest security features and not left vulnerable to attack. In essence, the cloud will change the way you work, with solutions being built in hours, not days, and applications operating with greater insight, enhanced security, and global reach. Just as the power of water and steam fueled the first industrial revolution way back in the late 18th century, the cloud is now racing us towards the realization of the fourth. A time when compute, automation, IoT, and data isn't just breaking innovation boundaries, but pushing us further than we ever thought possible. The question is, what will you do with it?
So, my conclusion here is that we have heard from the owner himself, the OEM. Okay, is echoing. Am I still echoing now? Please, can you confirm whether I'm echoing?
No, you are not.
No, you're
No,
not.
sir. No, sir.
Okay,
No,
thank you. So, cloud computing is delivery of
echoing.
computing. Okay, computing services through internet, basic. Now, that is the first pillar that is bringing about digitalization, transformation. Now, it's not a myth or somebody in the cloud. It's just somebody using computer, although so many believe started when cloud was introduced, believe like security, just a video of address it, coverage, connectivity, but this has been broken down that it is possible to have access to this service anywhere. Now, one major factor that is always pressing and is still very, very much around us is government policy. And we can see what Nigerian government is doing about information management process. Laws are coming to mitigate against people having access. And public cloud is another way where you can put your details out there in the public space. How do you mitigate against? Government is coming to regulation, and that is being dealt with. Even at this time, with cloud innovation, the power of the cloud, we can still see crop growing even in gold mine. That means things is possible, will be possible at the speed of time when you initiate cloud environment. So it save you costs, it bring agility, it make it flexible, and it make your sovereignty, especially, it allow data center across the whole world. At least we have 65 for Azure across the world, plus 65. I think it's going to 70 at this count. I checked the last time when I checked the cloud offering. It's about 70 data center around the world now, and it's increasing. That means we're having these services all around. Cloud generally is basically based on some model and type. One of the model is on-prem, where you have all the power, all the authority, you build it ground up, and the cost is on you. The other one is infrastructure, where is a percentage of 60 to 40. The cloud offers you 40%, which times of storage, security, networking, and the rest, while you take care of the software, the installation, the data, and the rest. Then the other one is platform and service, which is more like 80 to 20. The OEM, Microsoft, take care of 80% of all the services, where you take care of just 2. That means your data and your application. While the software as a service, which M365 is an example, Microsoft take care of everything. If you have ever gone to Amala Ibadan, is a typical example. Walk into Amala Ibadan, there is one at Igodo area. Walk there, real Ibadan Amala. When you eat it, you know you are eating Amala, freshly baked from the flour of the yam. So what is that? When I walk down there, I don't need to know where the water is done, how the Amala came from Ibadan. All I need to do is sit down, pay for my Amala, eat it with Begiri, and I'm out there. The only relationship I have with them is my card. The same thing with software as a service. You don't need to have anything done by yourself. You don't know where the server is. All you need to know is how to access your application and have it used. So having that, let's bring it down into real estate. Real estate now. In real estate, we can say is a choice you make. And those choices lie with when you want to build on your own, ground up, that is on-prem. When you want to have a space, just a small space where the house is being managed for you, the power and the rest is called infrastructure as a service. Or when you want to just walk in with your family, all the house is bought, the infrastructure is there, you just bring yourself and your data, that is platform as a service. And finally, walk up into an hotel. You stay there in the hotel, you have a luxury stay, and you just pay through your card. That is software as a service. Now, having this brought together, there are actually types of cloud computing. We have the private one, where an individual, a company, have his own data center and is servicing their resources. Then we have the public one that Microsoft, which we are using now, which we are going to use to build our AI infrastructure, is having a public surface. It's talk to every other person that wants to have access. Then we have the hybrid. Hybrid is a combination of the private and the public cloud coming together to make the power of computing ready, available for people. Now, the force power, again, he has done it. Sorry, again. The force power here, we have seen it. Now, let's look at the second potential driver of digital transformation, which I call data. Now, data generally has been one power that we cannot overemphasize nowadays, because data has come to stay as a major yardstick to making things change for the industry. Now, when we look at data, what we can see is massive inflow, lot of change across mobile app, smart systems like IoT, network, connected services, storage area across the world. All of them are bringing out data. And data now has brought about a little change. Now, data, sometimes we can describe it as raw facts, symbol, sometimes information that are collected for references. And they are categorized into 3: structured, very organized, stored, predefined into a format like row and column. Example is spreadsheet. Unstructured, more complex format, but actually the information there is key. Example is video, email, social media post, and PDF. Then when you combine these two, into an application that is web facing. We tag this as semi-structured data. Now, what is data? Data is a norm where you can scale. Data is a way by which you categorize information. It can be things you can put in ratio of a scale. It can be qualitative and it can be quantitative. And each of them are measurable. And that is one major thing about data. You measure it with interval, for example, like ratio, like temperature. What is the ratio of Kelvin? There's going to be cloudy today. There will be heavy rainfalls because the temperature is about 75% against 85% when it's dry season. That means there will be rainfall today. So you use data to measure things. Now, apart from that, we have data has a way by which you can do what we call conversion. What is conversion? Conversion is a way by which we convert the norm value to things that we can read, like numeric, like field. And sometimes we compress this into figures because computer generally it's garbage in, garbage out. They don't understand human language. So they are represented with numbers, and data play a very good role there. So in essence, two major data that is making wave. Let's just quickly look at the difference now. Structure, unstructured data. What is structured data? Is organized, fitted, and properly formatted into field. Unstructured data are not specific, like I mentioned, PDF, video, and the rest. You can see in terms of storage, data accessibility, all of them have different ways. So in this field, we are seeing a combination of these two bringing about the massive blow of data, where they say data now is what? The oil. But when you now bring it home to AI, because where we are going, remember, our flight is to go to AI fundamental, is where is data. Cloud is giving you the power, the engine. Data is giving it the feed. And before you can get a perfect model, you must understand that you have to feed it and prepare it. Now, apart from feeding it, you now have to bring quality out of those data. That's why you have EDA, you have cleaning of those data, bringing those data into accuracy, making it is complete, consistent, is timely, is valid, and making sure that is unique when the AI model is using it. Now, all this brings us to three major pillars here that we can use to build data ready for AI. Collect it, clean it, and prepare it. Collect it, clean it, and prepare it. Fine. Now, when you now have the engine cloud, you have the data, then there's a relationship that is coming out from it. And that relationship is fueling the power of intelligence, which is now referred to as what? Artificial intelligence. So, in essence, the intelligent aspect of digitalization comes as a result of modernizing your business need with digital tech, using intelligent tools to create model and algorithm like AI, like machine learning, and the rest. Then creating what we call automation, back up with business insight to bring about a timely fashion model that can give businesses an head start when they make very quantitative with decisive decision. So at this point, a lot of strategic is coming in when it comes to AI. Privacy, as I mentioned, systems are being onboarded with what we call responsible AI. Recommendation is coming from the offshoot of data being drilled. We are seeing a building of things that can bring investment to business and creating a circle. So we are in a global circle that is making technology evolve. That's why we are having this buzz about AI. But one thing we have to know significantly here is that AI can be scaled now. The convergence of these three powers, superpowers, data, cloud. Cloud can bring scalability. Data in cloud can bring scalability. The consumption of data in cloud can bring AI to be scalable, to be innovative, to make your make it cost effective. Building on project management principle, we are going to see one model that Microsoft has introduced as a tool for creating AI called AI, Azure AI Foundry, a system that imbibes DevOps, project management into the same system and combine it with software development and coding. But mind you, the coding is not from the professional point of view, but from low-code point of view to the professional point of view. So all this can improve AI. So we are in the period of intelligence, and that brings me to fundamental of AI concepts. What is AI? Obvious question that comes to our mind. One, a behavioral pattern that occur when you bring a program, run that program with injection of data to behave externally like human. What do we do externally? We can see objects, detect those objects. We can view and know where we are at the location and the entity we are. We can understand language when we hear them. Is it English? Is it French? Is it Yoruba? Is it Hausa? All these are obvious questions that we answer, human do externally. Now, some internal thing we do, like neuron connection within our brain, our body system, to make movement, to make changes, to make stimulus. Can we build all those obvious concepts into a computer rather? And these are what conceptualize this to give us the obvious question about AI. What is AI? AI is software imitating human capability. AI is a demonstration of a machine, a computer that can naturally, similarly to human intelligence. Now, the concept of AI runs across the intelligent himself, simulating as human, building those concepts, use machine learning, which is a subset of AI, and there are different areas of machine learning, supervised, unsupervised, and reinforcement. We're going to go into it shortly. Now, what is supervised? Now, I don't know how many of you watch movies. I watch movies, and one of the movies I watched in those days, the Chinese film. Well, some people look at their concept as they just see, my master. Sorry, I'm using vernacular. They'll start fighting, chomp, 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 chomp. Now, at that point, there is a guided principle by the master that is going to give the person is training. Now, each of these concepts are labeled. You see some, they call it monkey in the shadow style. There is something they call snake style. Now, when the master is teaching this person, is guiding that person, is supervising that person. And that is what supervised learning, a teacher, training. So there is an objectivity. There is a label for each of those data, and that is supervised. What is unsupervised? Now, it's a pattern where you throw somebody into the water and said, know how to swim, like the Ijaw people. They throw the child into the water and said, if you are a true Ijaw child, you float. And sometimes, obviously, it worked. So that means that they are unsupervised. It is by the waves, by what is happening in the environment, that these get trained, and that is unsupervised. Now, what is reinforcement machine learning training? Reinforcement machine learning training is more of try and error. I put an hot water on the floor, and I told my baby, go and touch it. Or my baby mistakenly touched the hot water. It's trying it. Is this like my bottled water? Is it like my drinking, what do they call it? Water bottle or feeding bottle? When he touches, his hand shakes. Oof, it's hot. At that time, he knows there's an error there. This is not my feeding bottle. This is different from it. Next time, put that child in the same spot and said, go and touch it. The environment, the feedback it gets makes him to see this is not right. And that is reinforcement machine learning model. Now, let's go deep. Now, there's a video I watched years back, and this video still makes sense to me. Just watch it.
Today, right now, you have more power at your fingertips than entire generations that came before you. Think about that. That's what technology really is. It's possibility, it's adaptability, it's capability. But in the end, it's only a tool. What's a hammer without a person who swings it? It's not about what technology can do, it's about what you can do with it. You're the voice, and it's the microphone. When you're the artist, it's the paintbrush. We are living in the future we always dreamed of. We have mixed reality that changes how we see the world, and AI empowering us to change the world we see. You have more power at your fingertips than entire generations that came before you. So here's the question. What will you do with it?
It brings me to the story of Mr. Frog. My friend called Mr. Frog here. Now, let me give you a background of Mr. Frog. Now, Mr. Frog is an animal that is aquatic in nature, that is still in the water. But sometimes he wants to get sunlight when it's cold. So he comes to the land. And for example, he came out this day and he came out to a very wonderful area with green grass. But there are some people that are after this Mr. Frog, things like snake, like human. And for him to camouflage, he changed the process of changing, the process of imitates the environment. And that intelligence here, right here, show us that there's possibility even from imitation of computing to make this happen. And that was what Alan Turing did in 1950. He weighed human knowledge, intelligence of human, and tried to build some machine that can significantly behave in the same pattern. And that was when the journey of AI started. However, what do I define AI as to? As I mentioned before, simulating human intelligence, algorithm computation that ensure it can analyze data, recognize pattern, bring about relationship, and put it in performance state. All bringing us into 5 major characters of AI. 1, ability to solve problem with reasoning. 2, ability to adapt by learning like a child. 3, ability to communicate to yourself. That's why you go to ChatGPT. You log in with your account and say, ChatGPT, hello. And he said, hello, Oluwaseyi. You wonder, how did they get to Oluwaseyi? Because there's an account with my detail, my profile. It tried to talk to me as I'm talking to Rashid. So this is natural language. Thirdly, perception, detection, computer vision, and speech recognition. Is it French? Is it English? And obviously translating from one language to another. These concepts bring about some key measurable solution within AI. Machine learning is 1, natural language process is 2, computer vision is 3, robotic and deep learning, where we look at our neural construction and use it to build what we call a complex relationship within data set to create an algorithm that we can use to build an AI model. We are at the point here, we are just building the foundation, the concept of AI. Now, over time, I guess what will be seen very soon is that I use this analogy every time when I talk of AI. Oh my God, not again. Sorry for that. It went down again. This is my, once I click my clicker double, it just go off. I'm sorry for that. That's the 4th time he's doing it again. I'll be careful again, more careful. Okay. So this analogy, I give it when I do my presentation that we are currently off this track now. I don't believe on all this, but science says The migration of man started from ape, it grows to another shape, another shape, another shape. Very, very soon, which is very real now, we are at this point where we are seeing computer in the form of artificial intelligence behaving like human, doing things that we can do, and making references and projection that we can do by the power of the data and the presence of the engine called cloud. Now, history tells us that AI has started long time, 1943. And you see, this is Turing sector when Turing made an analogy between human, and this is John McCarthy, 1966, when he did the conference. And over time, this has grown. You can see people that have started way back. You can see IBM with checkers, checks. They create a checker. That was the first AI algorithm created through checkers. Then you see things like Google started with 2012 with Google Now, and Amazon started with what we call Amazon Echo. However, the sudden burst we have today was in 2020, from 2020 to 2021, when Microsoft have a relationship with an open source called GPT. They call them OpenAI. Now, they created a chatbot that can reason using what we call a generative model, a transformer model that can reason, create, and build from the content you have. And this can be done over the internet. Unlike when IBM and the rest did their own, they are all built it around a small subset that can make them do that. So history is still playing out that there are several of area of AI that we can see today: artificial natural network, machine learning, natural language process, robotic, Internet of Things are all bringing about the convergence of AI. Now, but before we go into the next model, which is fundamental of machine learning, let's now drill down to types of AI. Now, I consider AI to be two types. One, the narrow AI. Now, narrow AI is considered as a weak AI, AI that specializes in performing a single task. For example, Siri, Alexa, Cortana, they are created with a voice input. They are created with a knowledge base through the web to get information, but each of these information are timely, faced with certain structure. They cannot think outside the box sometimes. They are confined with the system. They are weak. Then we also have the other one, which is the general AI. The general AI is where we have the generative transforming AI through ChatGPT and co, where we have the capable of consciously awareness. As you are injecting the data, they are propounding policy, creating awareness within themselves, captivating those information and recreating it into things that can be used for human. They are not weak, they are strong, but they need more dedication, and that is the future of AI. However, Microsoft's approach to AI, as we start rounding up this first model, is knowing that it's built on democratization, where we have agent, application, service, and infrastructure all created into these three major ideologies. Create the idea, pre-build the AI for you, for their customer, so that at any time they can just inject their data and create their solution, and the programmer or the software developer create a point of consumption to their customer and to the internal user. That brings reality to this AI. So Microsoft had a lot of AI services, which was formerly called cognitive services in terms of vision, speech, language, knowledge, search, and also building it yourself through the machine learning lab that we have. So these are common workload we have in Microsoft Azure AI. We have machine learning for prediction, computer vision for getting vision in terms of video, images, natural language capable of knowing language, interpreting language, and speaking and translating those language. Document intelligence, taking it across from just what human can do, but our processes, one of our processes to capture information, data, and document intelligence is capable of dealing to that aspect. And we might want to have a place where we have large source of knowledge called knowledge mining. And that is where we can build our infrastructure, inject our structured data, inject our unstructured data, even our semi-structured data, to give us a knowledge base that can people use. And finally, the boss about GPT, OpenAI, called generative AI. An AI capable of bringing originality from code to image and to text. Now, having that said, let's now look at the subset that can bring about risk when we talk of AI. And one of them is risk when you are building this solution. If you have bias, for example, and you are giving loan out and you create an AI with bias, it's going to give an output that will bring error. If you have automobile industry, you don't test it properly, and you put like a self-driving car in Lagos without having ability to detect other cars, it will bring an error. And it goes on and on from medical to crime to financial industry. There's a lot of risk that's coming and challenge. Now, I was watching a film some days ago, and that film, the guy was running a syndicate, which we call 419 system. And he has different cells. Now, he got a guy that is a program developer, and he developed a program to AI that whenever you want to confirm, for example, if you get a call that somebody, I'm talking about risk now. Now, somebody called you and said, oh, your husband said is in need, you need to send some money for mechanic, blah, blah, blah. When he calls you, the first check every human do, who are you? And we quickly do a video call. First check. The AI model that the guy created, bring the picture of the guy, simulates the way the person talks, the voice notes. And the person now talk to you. You think is real. Meanwhile, it's an algorithm. So you can see how people can concept that in a movie. What's reality? So there's a little bias that we have in our society when it comes to AI. And that bias is about when you train this, what is society going to see to it? How will the norm take it? And those bias trickle down to Microsoft creating what we call principle of responsible AI. Before you create an AI solution, you must know that you need to create it with fairness and the rest. However, let's hear the story from Accenture when it comes to responsible AI.
What is responsible AI? Imagine you're driving down the freeway. There's a slowdown up ahead. So you slow down. But what about after it clears up? Will you stay at a slow speed just in case at some point traffic slows down again? Of course not. You'll drive fast again knowing that if you need to use the brakes, you will. Those brakes do for your car what responsible AI does for your business. It lets companies implement AI at scale with confidence. Knowing responsible AI can help avoid problems up ahead or even course correct, all by making transparent, trustworthy decisions. Companies using AI to help identify and recruit candidates run the risk of perpetuating inherent biases in the data, drawing on practices that might have skewed to one group or another in the past. But responsible AI can help them recruit and consider a broader pool of qualified candidates. We hope this was a fair representation.
So, responsible AI, fairness, everybody should not be stereotyped when you are building your AI solution. 2, safety, and it must be reliable. 3, privacy must be checked, security must be intact. Inclusive, everybody, anywhere, any place must be included in the solution, and it must be transparent. Ensure you tell them, I'm using ChatGPT 4.0. The limitation is that you cannot do beyond. That's why sometimes when you ask on ChatGPT some question, it tells you it was trained last by this time. It doesn't know what is happening in 2025 because its age at this time is 2023. It cannot give you information of 2 years after. So you must be transparent when you are creating your model. Finally, you must show accountability. Whatever you build, how you build it, you must be accountable to it and ensure that the solution has the value that you want to drive with it, and you are able to work with it accordingly, and you don't move, you don't go beyond there's that setting you want in terms of accounting for it and ensuring that these are built in specification of what you want. So all this brings us to light that AI has actually come to stay. Now let's quickly go to the second module, which tells us about another area of AI called the machine learning, fundamental of machine learning. So what is machine learning? That's the first question we ask ourselves. What is machine learning? Now, machine learning is actually a technique where we create a solution that can, my God, why is this doing that to me? Yeah, I should not use the clicker. Let me use the keyboard. Sorry, guys, sorry for this. It just go off. And it's taking my time. I'm very sorry for this. I'll bring it back. So what is machine learning? Machine learning generally is a technique where we use to create predictive model based on relationship of this data. You have a data set, you check the data set for competition, for comparison, and ensure this data set can give you that inference or output you want. Then you can describe this as described here.
Machine learning. Teach a computer how to perform a task without explicitly programming it to perform said task. Instead, feed data into an algorithm to gradually improve outcomes with experience, similar to how organic life learns. The term was coined in 1959 by Arthur Samuel at IBM, who was developing artificial intelligence that could play checkers. Half a century later, and predictive models are embedded in many of the products we use every day, which perform two fundamental jobs. One is to classify data, like is there another car on the road, or does this patient have cancer? The other is to make predictions about future outcomes, like will the stock go up, or which YouTube video do you want to watch next? The first step in the process is to acquire and clean up data, lots and lots of data. The better the data represents the problem, the better the results. Garbage in, garbage out. The data needs to have some kind of signal to be valuable to the algorithm for making predictions. And data scientists perform a job called feature engineering to transform raw data into features that better represent the underlying problem. The next step is to separate the data into a training set and testing set. The training data is fed into an algorithm to build a model. Then the testing data is used to validate the accuracy or error of the model. The next step is to choose an algorithm, which might be a simple statistical model like linear or logistic regression, or a decision tree that assigns different weights to features in the data. Or you might get fancy with a convolutional neural network, which is an algorithm that also assigns weights to features, but also takes the input data and creates additional features automatically. And that's extremely useful for data sets that contain things like images or natural language, where manual feature engineering is virtually impossible. Every one of these algorithms learns to get better by comparing its predictions to an error function. If it's a classification problem, like is this animal a cat or a dog, the error function might be accuracy. If it's a regression problem, like how much will a loaf of bread cost next year, then it might be mean absolute error. Python is the language of choice among data scientists, but R and Julia are also popular options, and there are many supporting frameworks out there to make the process approachable. The end result of the machine learning process is a model, which is just a file that takes some input data.
If someone says echoing, so I have to stop it. I don't know. So generally, what the video is
in the same shape that it was trained on,
taking us through is to build what Arthur Samuel said in 1950, I think 1959, where he did a checker. Now the checker is like from a chess system where he built a field of intelligence through computer and allowed that computer to know what. My voice is also echoing. Okay. Let's see. That's another one.
No, your voice is not echoing.
Okay, thank you.
Fine.
Yeah, I'll share my screen again. I unshare it to see whether it's from the share. Let me share again. So now traditionally, let's now compare machine learning with normal program. Now, for a program, that's why it's not really when talk of machine learning, we are not talking of programming in quotes. We are actually looking at a way by which we put three different things together. One, okay, I'll do that. Thank you, Jimmy and Jamie. So one, you bring the program that feeds it, you inject the data to give you what? A comprehensive output. So in traditional program, what we do is that we put an input. There's a logic that if A is for apple, choose apple as A. If B is for ball, choose B as ball. So that is a logic, provision to run in a program to get an output. But machine learning is when you feed an input and output at the same time. That means you feed your data, which is the input, and you tell the data what is the outcome that we get there. And that will bring the program for you for evaluation and testing. So let's take a dive into it and look at some common terminology we are going to start hearing when we use machine learning. One of them is model, which is like an hypothesis, which I mentioned here, putting the data input and the output, the hypothesis you want to see at the end of the tunnel. Then the feature is like a measurable part. It can be in percentage, it can be in figure, where you'll be able to know that the measure for good model is 50%, is 30%, is 4%. So each of them is the future. Then you have target, which is more that like when you label something. Then you training, when you are trying to bring the model to speed. Prediction, when you have put the output and the outcome you want to get is a prediction. Then other things like accuracy is like a scorecard that you see during machine learning model that tells you that this is what the machine learning model is doing. 2, precision. Every time you inject data into the model, how many times is this right? That is yes. That is precision. A recall is whenever you inject the data and you now count how many years. For example, I inject 100 apples into the model. 100 fruits into the model. Out of the 100 fruit, 50% are orange. 50% are not orange. So your recall ratio at that point is 50%. Now, what is FI score? FI score is now bringing the yes you get from precision and the yes you get from recall, merging together and dividing into percentage to give you the score of that particular model. So let's now break it down. This is me, Oluwaseyi. I'm a young guy. That's hypothesis now. Not really Seyi as Seyi here, but Seyi as in my story. Now, Seyi was born in Odo Town, and his grandfather came from Okegbo, a village in the remote part of Ondo West. And he lived all his life in Okegbo. What does he do? He was a farmer. He goes to farm with his parents. Now, all his experience over the time has been in the farm. This is Seyi. Now, one day, Seyi met, for example, Rashid. And Rashid look at Seyi and say, Seyi, what are you doing in Okegbo? Okegbo is a remote area. Come to Lagos. Fine. Papa, you travel, we came to Lagos. And as Seyi was going, he saw a red buggy eye car that looked over. And what Rashid asked Seyi is that, what is this? This object? For the question Seyi asked Rashid was simple. It's a car, obviously. Rashid lived all his life in Lagos. He understands automobile. He sees them every day. He can mention and detect them as they move. Confusion to Seyi. So Rashid now asks Seyi, what is that object? Do you know what comes to Sheyi's mind? All my 40, 30 years in Okegbo, I've been in the farm. What is my mind is the animal, the plant, the bicycle, everything I see is what is that. So there is nothing in my memory that can depict what Rashid mentioned as a car. So obviously, I don't know a car, I know the farm, I know my animals, I know the bicycle, and that is it. That is my memory. At this point, Sheyi memory is tied to his past, his experience. However, humans are built with the capability to observe and learn, observe and learn, observe and learn. Then Rashid puts it upon himself that I must teach Sheyi what this is about. Because he cannot be in Lagos and every time he see a car, he call it a cow. Anytime he see a car, he call it a goat. There's something wrong. I must put a stop to this. And Rashid started the journey with Sheyi and said, Sheyi, I will show you all these objects. The first one is a red body high one, round over, is called a beetle. Red beetle. Sheyi recite red beetle. He entered the experience curve of Sheyi. He now saw another car. A rectangular car is called a Toyota. It's blue in color, it's called a Toyota. It's registered in Sheyi archive. Then he now told Sheyi, Rashid now told Sheyi, come. Although I've been showing cars, there are other means of transport you don't know of. One of them is called a superbike. A superbike. And that superbike is red in color. That data, that information stick to Sheyi. And the last one is a blue car, bicycle. So in Sheyi's line of learning, training Sheyi to understand the automobile industry, a lot of things came to Sheyi now as Rashid trained him. The car, the red buggy, blue, red oval car called B2, the blue rectangle car called Toyota, the super bike red in color, and the normal bike in blue color. Now, Sheyi has acquired more knowledge, more experience. Now, if I ask Sheyi after a month, after 2 weeks, after going through this with Rashid, and somebody just see Sheyi on the road, as walking on the road and say, Sheyi, what is that object? What comes to Sheyi's mind is a car, because he has passed the farmland in Okegbo, the animal, the cow, everything. He has passed it. Now, what he's thinking is that it's either a car, the buggy red one, the blue Toyota, the bike, the super bike, or the normal bike. And he can answer precisely. Now, let's now take a walk to machine now. Computer. What is machine? Generally, machine is garbage in, computer is garbage in, garbage out. So how does computer precise its information? Computer follow instruction. That's why most applications that run on computer are basically program language, program instructions. So computer can add and subtract and multiply. Computer can do more things apart from adding, which are basic things that we can see in normal, even calculator. It can do comparison. It can bring output by printing. It can plot a chart. That means further instruction on a computer bring further output. What am I saying? Now, let's now bring the dodgy words together. Machine and learning. What is machine learning? Machine learning is a way by which a computer are built to observe, like Sheyi, a young boy from Okegbo that don't know anything about town, about the cars, but Rashid, a Bolivian friend, was able to supervise him, train him. Or Sheyi came to Lagos. After 1 month, he knows, oh, the red car, the blue car, he started observing without any supervision. Or when Sheyi mistakenly see a car and call it A cow, people shouted at him by the environment and said, what are you? Are you archaic? At that point, Sheyi has learned by reinforcement, by the environment. Oh, I should not shout cow for a red, dodgy red car. It is called a B2. That is reinforcement training, machine learning. Now, the concept here is that computer learn. It learn prices. It predicts prices. Computer wants to talk to you as human by infusing instruction into it through what we call a model algorithm. Computer want to recognize objects by using the pixel on your face, taking it as what? As a shape, and using that shape to recognize you. Computer want to tell you, like Sheyi, the village guy, like Tarzan, if you have watched the film before, you notice this guy doesn't know anything about the city. He was an arcade, animal-oriented human being. Despite the fact he was born by a human, he behaves like monkey. Why? Naturally, his experience curve has been on that. So what I do, how I behave, now infusing it into computer system is what is referred to as machine learning. So the computer with the data set you injected, making sure you inject the output you want to get, which is the hypothesis you want to put, that brings an algorithm. Then you now begin to put the checklist. What is supposed to be? What is supposed to be? Once you check those checklists and it meets to it, it became an extracted information from it. You can identify from that relationship, it become what? A model. And that model is what we now interpret here as what machine learning has done. So machine learning, a solution that identify, create, using data to perform a way by which it requires rules, pattern, and relationship to give you an output of a decision. So, type of machine learning, which I've used methodology to easily explain it. We have the supervised, which is more of training the set, having it, making sure that you have a label to it, you have a title to it, and it gives you an inference, which is now the bullseye, which you use to identify from this reference, any card that come now, you can easily identify it because it is classified and it is supervised. Then we have classifier also as part of supervised, where you have groups of data sets and you group them in groups, and each of them, when now you now bring a singular, and for example, this example, they bring a singular elephant here, you could identify that this is an elephant. Then regression is in terms of numbers to get how it grows, the output by function, by creating a function with the value, which is called regression. So classification and regression are an example of what? A supervised one. Unsupervised one is where you don't label it, you throw it into chance. Now, the system now begins to create what we call clusters by bringing it together into group. And once you group them, it brings a relationship within the data set. This group is related to this. Like, for example, a bike is related to a bike helmet. That means anybody that is driving a bike must have an helmet. That association now make it unsupervised and can easily use that to detect those function and create an algorithm and a model from it. That's why you see some shopping lists. For example, you want to buy a computer, and as you are shopping for the kind of HP or Dell, the computer or the platform where you are buying for is telling you there's a keyboard, there's a mouse, because in the data set, there's a relationship that has been added in the grouping of those computer accessory and computer. It has been relative in the data set. So it can relate that to you and tell you, as you are buying computer, you should buy a camera, you should buy a mouse, you should buy a keyboard. So reinforcement, as I mentioned, like a dog, for example, you teach a dog how to relate with you. Like, for example, this girl is teaching the dog to throw, the dog is like the agent, the girl is like the environment. You throw the stick and the dog action for him is to go and get the stick. Now, if this girl change it to a ball, the dog takes time because it's not a stick. It might not go. So he learned until the girl now beat the dog and said, there's a reward for you if you pick stick, and there's also a reward for you if you pick ball. By that action of that try and error, the dog can pick with the action. Also with the baby, I mentioned the baby touching an hot water that it thinks is his feeding bottle, and afterward, because he has learned and somebody shouted, no, don't take that, it's hot. The baby learned that you don't take hot water for feeding bottle, and at that point, is reinforcing the learning. So other things that come in, apart from the regular machine learning that we have deep learning. Now, what deep learning is taking it further, taking the concept of neural structure, where we now bring a natural connection, now mimicking a system where we have interrelationship, a broad base of data, increase of data, and using it to make sure that they are connecting. And the convention is technology here is to create a way by which you can bring this connection into future, like healthcare. You are sick, the system should be able to know your name, know your history of medication, what you have done before, and bring it to light. That connectivity, just like a neural cell, is what deep learning gives us. So as we start winding down, we now need to know about AI services on Azure. Now, AI service on Azure basically is built on the cloud, where you have the subscription, which is basic. The magic word for Azure is subscription. That is money. Ewo, kudi, naira. Now, if you don't have that, you might not be able to have access, although they give you premium to have a trial for 200, or if you're a student, you can have access to Azure. But if not, this basic is important. And the other one is resource group. Resource group, I told you about my grandmother. Now, one unique character of my grandmother also is that he has what we call, she ties something like a pocket around her waist. And every time, everywhere she goes, she ties it, and I observe it. Now, in the recent time, when I look at resource group, it's just like that. Resource group is just like a container where every resource you want to use on the cloud platform of Azure, you can store it. You can distinguish it into two. It can be just as a container that really is only for one particular feature, one particular service. Or it can be a container that has every service there. So you can easily manage the cost, manage the content, you can look at what is happening, and you can even know what is happening with the region and etc. So the basic design of Azure services is it has a storage, it has a computing, and is running on the service, AI services on Azure. So the key service that we have on Azure today is OpenAI service, which is an adaptation of OpenAI that is embedded into Azure after that relationship with OpenAI service, which is commonly called GPT model. Then we have cognitive services, which include vision, speech, language, decision-making, and search. Then we have the model itself. If you want to create your own model, you can use Azure Machine Learning. Then you have Azure AI Search. It's not just a search engine, but a search that is powered by use of what? The cognitive services. Then we have Azure AI bot services, no more in existence. Now everything is more going to the generative AI, which we are now talking is now called the agents. So this is a typical design of the services. How we can consume it? We can consume it as a standalone services. You can consume it as a multi-service. Like where we're going to do the lab is the demonstration is called Azure AI Foundry, which I'm quickly going to go there because my time is on. I don't have time again.
Yeah. Hello, sir.
Okay.
Well done. Well done.
So I'll be winding down at this point. So in consumption of the application, you can use REST API, which is the endpoint, and you can use the authentication key. So in real world, a lot of AI services are around there in healthcare, in finance services, in commerce and e-commerce, which is practical for us. An example is Netflix. In warfare and transportation. If you have follow Iraq and Russia and Ukraine war, you can see how they are used drone to be able to bomb people specific location and drop certain bombshell around the world. And you can see how vast AI has come to stay. You can frame it up in business by making sure that you are clear about it to decision maker. You have the right data and you can translate it into quality, especially the quality of data determine how your AI would function. So I'll leave you with this video if I cannot do the demonstration. This is a video about Azure AI Foundry that tells us about the unique nature of what we can use AI in one go.
If you're looking to create agentic solutions and want to move quickly and efficiently, Azure AI Foundry is the one place for discovering and accessing the right building blocks for your agents, with everything you need for AI development.
Hello, sir. Please unmute yourself.
I mute myself. Is it still echoing?
No, we could no longer hear when you muted yourself. That's why.
Oh, sorry. Okay.
Implementation, coding in your preferred and efficiently. Azure AI Foundry is the one place for discovering and accessing the right building blocks for your agents, with everything you need for AI development. Today, I'll share the essentials for Azure AI Foundry, starting with a tour of its extensive capabilities as a unified platform that supports you throughout the entire AI development lifecycle, from initial concept with early experimentation, coding in your preferred IDE, pre-production assessment, management in production, and beyond, followed by a real example of the steps for creating a multi-agent application using the new Azure AI Agent Service in Azure AI Foundry, all integrated with your code. Starting with our tour, you can easily reach to Azure AI Foundry at ai.azure.com. And once you've created a project, panning down the left rail, you can quickly see the core experiences. First, the model catalog helps you discover and access a growing collection of thousands of models to power your individual agents as you build your systems, including premium large language models from OpenAI, Meta, DeepSeek, Cohere, and more, as well as small language models like Microsoft Phi. And of course, there are hundreds of open models like those from Hugging Face for you to try out. Models are also available by area of specialization. For example, there are regional and focus models to support interactions with different spoken languages, like Mistral for European languages and JAIS for Arabic. And separately, there are industry-specific models that you can choose from. The entire model catalog is hosted on Microsoft's supercomputer infrastructure in Azure for optimized cost performance. Next, in terms of model deployment, you can choose to run models on hosted hardware with managed compute. And for dozens of our popular premium models, you can use our serverless API option. As you use Azure AI Foundry, you can, of course, also bring your own models to run on your Azure infrastructure. Then, to help you choose the right model for your agent, you can easily experiment in our playground. For agents, you can add knowledge to ground your model. You can choose files to upload, use existing search index, or add web knowledge using Microsoft Bing. There are also options to add data from Microsoft Fabric, as well as SharePoint to connect with data in Microsoft 365. You can also define actions for your agents to perform, like calling APIs, functions, or using Code Interpreter to write and run Python code to automate processes. And back on the homepage, clicking into AI services provide additional task-specific capabilities that you can use to augment your agents, like speech, translation, vision, and content safety. So right from the start on your application design, you can leverage Azure AI Foundry to evaluate AI models and services for your application.
So I'm supposed to have a lab here, but I don't know whether my time will give me that to show practically. I'm going to create an inventory agent I'm also going to create a transport agent, multi-agent on my agent, and we can now start creating the model and testing it. But I don't know, Franca, my time is up. I can stop here. Maybe next time we'll do the lab. Or if you can give me 5 minutes to just show it.
Will 5 minutes be enough for you to do the lab?
That's a good question. A quick one. I can do a quick one, but it might not be expressive.
Well, okay, so my suggestion is that this class also have ended by 3:30, and this is 4
My
o'clock.
God. Yeah.
This is 4 p.m. So I will advise that you can help us record the lab and send the recording to us while we also have this. So that will work for us. So to enable our participants to also go into other various business of the day that they have already. So thank you very much. Maybe you want to give closing remark before I come off again?
In closing, it's just Q&A. And to tell everyone that the journey starts from you. You have to start beginning with it, start building, and I'll send the video and we start using that. But the concept here is that the world has changed. We are in the fourth revolution and AI is behind it. Thank you.
Thank you very much. Thank you very much, Mr. Sheyi. We really appreciate your time for being with us. We want to appreciate everyone for being with us as well on this call. Please, we have dropped the feedback form on the chat. Can you kindly help us fill the feedback form before you exit the call, please? It is very important to us. I would like, if you have filled the feedback form, kindly give me a thumbs up. And if you have filled the feedback form, kindly give me a thumbs up. And please, let's appreciate our facilitator on the chat. We want to see your emoji. We want to see your thank you on the chat. If you have actually benefited from today's class, please. Thank you, Madam Franca. Thank you, Mr. Albert. Yeah, thank you, Mr. Shitu. Thanks, Madam Franca. Let's appreciate our facilitator on the chat, and please let's fill the feedback form. If you have done so, can you just drop on the chat, done. Thank you. Love you too, Mr. Shitu. Thank you. Great training. Thank you. And if you also have questions for Mr. Sheyi, he's still on the call. Kindly drop your questions. He will compile the questions and post the answer on our WhatsApp group chat. So if you also have questions, please. Thank you. Oluwa Tubosun, thank you. Tosin, thank you for filling the feedback form. Please, let's have more people fill the feedback form before we call it a day at 4:05. We are going to call it a day on this call. Please, let's fill the feedback form. Thank you. Mr. Sheyi, can we have the PowerPoint of your lectures as well? Mr. Sheyi, are you still on the call?
Yes,
okay,
I can.
So there's a question
I can share it with you.
Okay. So you're going to have the PowerPoint slide. It's going to be dropped on our WhatsApp group chat, please. Thank you.